And we're going to do problem 11 tonight as well. 2025 AMC 12A problem 11. The orthocenter of a triangle is the concurrent intersection of the three possibly extended altitudes. What is the sum of the coordinates of the orthocenter of the triangle whose vertices are as given here? By the way, I just noticed just now as I was writing the problem, I wondered where some of the other trap answers came from. You might know the property of the centroid is the average of the coordinates. That's one of the centroid properties. Probably write that in your small notebook. If you were to add 8, 18, and 2 and divide it by 3 and add 27, 27, and 31 and divide it by 3, you would get 113 over 3. So kind of fun. I wonder how many people knew that concept and got it twisted or mixed up with orthocenter. There's not really a way to know exactly how to begin, and so when you don't know what to do to begin, you just start adding information, as in, maybe if I graph the points, some good things would happen. I do notice these have the same y-coordinate, and maybe we can do something with that. So we'll go over here and we'll draw a graph, I guess, on this side. And I don't want to draw, actually I don't even want that much of the graph. I only want the first quadrant. And I'll just draw that here, and we'll go here. And I'm going to go 1, 2, and put a random point up here and call it 31. So that's my point, 231. Then we're going to graph 8, and I'm just going to rough estimate 8, 27, and 18, I'm going to call that 27. So this is 8, 27, and 18, 27. Now you're looking for an orthocenter of a triangle, then go ahead and connect the dots. Now an altitude to a triangle does not have to be inside the triangle. It's a known property that it just has to be perpendicular to the line that the base is on, and all three sides can play the role of a base. You could draw here to make that one, but I don't want that one. I see right away a benefit to that 27. If I extend out the line, y equals 27, my altitude has to drop and hit it at 90 degrees, which means only a line x equals 2 will do that. And since that x equals 2 is the graph of one of your altitudes, the x-coordinate of your orthocenter is definitely 2. So then it's somewhere on here. All we need is one more, and you have to pick now, do I want to try and do this one? And you could use the distance from a point to a line to do that if you wanted, if you know that formula. But I'm going to probably go with the other one if I extend out this way and just go here. And again, mine's not drawn accurately, so I don't need to worry about where it intersects or anything like that. I just need, and maybe that's not quite 90 degrees. Probably the scale's off a little bit because I kind of know where it's going to hit, and that's not it down there. But we don't care. You conceptualize the drawing. You don't look at it as accurate representation. We just need to use it for thinking purposes. So if I find the equation of this line, and don't I know its slope, I'm going down 4 and over 6. So down 4 over 6 is negative 2/3. That means that any line perpendicular to it has to have negative reciprocal slopes. Write that in your small notebook. It's a small notebook concept. So you have negative reciprocal slopes, and you're going to go this way from this point. So we're going to use point slope form. And you're going to say y minus 27 equals, I need a slope now. The slope is the negative reciprocal of negative 2/3. That means it's positive 3 over 2 x minus 18. Now what I'm looking for, I want this line that I just created to intersect this line. And if that line's called x equals 2, that means x needs to equal 2. And so you're going to put 2 into here. You're going to get negative 16. 2 is going to go into negative 16 as negative 8. And y minus 27, hold on, what did I do wrong? Something's not right. So my slope here was down 4 over 6 in the positive direction. So it was negative. I should have positive 3 over 2. And I'm using x minus 18. I don't know, something feels wrong. Let me see. Make sure we're doing this right. Y minus 27 equals 3 over 2 times negative 16. 2 goes into there, negative 8. Oh, that's the problem. There's a 3 outside. Cool. So then we got negative 24. And then you're going to add 27. And when you do so, you're going to get y equals 3. Great. If y is 3 and x is 2, that's the coordinate of your orthocenter. This is simply coordinate geometry. You can probably find this in any geometry textbook of the modern era. They put a lot of this stuff in there, having you find orthocenters by various means. You could practice it by giving yourself 3 coordinates and trying to find the orthocenter of them. But many modern geo textbooks will have it. If you wanted to pick up a used one and go practice, I'm sure Khan Academy has things. You could probably just Google worksheet for coordinate geometry of orthocenters given 3 points. And then you could find problems like that. So yeah, 2, 3, add those together. The sum of the coordinates is 5. Hope you enjoyed the solution. Catch you in the next one.